so then by doing that, those underlying models, the foundational model piece, start to understand like all the features in the data, like what things look like in remote sensing data, right? Earth observation data, for example, or now weather and climate data from different models. And so the nice thing is that you can train those foundational models, and that's a very computation intensive thing, right? It takes a lot of effort to do that. But once you do that, you can then take those models and fine tune them for a range of different downstream applications. Okay, so for Earth observation, you can do things like segmentation, so you can use it to automatically map where flooding has occurred, burn scars from wildfires. You can do classification tasks like land use monitoring and mapping, forest monitoring.
But looking at the patterns of the data, can we predict when the flood is going to happen or when the tornado is going to come? Or earthquake is going to happen? Yeah,
so with the Earth observation models at present, they're historically looking, right? So you're taking images of what the satellites have seen, and then you're extracting information automatically from that.
Okay.
The weather and climate models, which I'll talk about in a second, have a bit more of a forward-looking forecasting capability. Right?
So have you achieved that thing, the forward-looking capability?
So we have some forward-looking.
How much is the accuracy of it? Like if I want to know when is the next earthquake going to happen in the US, can you predict that?
So for something like earthquakes, we wouldn't at the moment. Although I think not for earthquakes. Although I think people might be starting to look at similar, like the appropriate types of data for that.
Okay.
With different things.
Okay. So how about like a flood or like a tornado? Can you predict that in the US based upon the next month?
Well, yeah. So for flooding, okay. So we've done a range of applications for Earth observation. We're now starting to work on weather and climate, and so there are kind of a range of applications you can use for weather and climate. So the first thing, which kind of comes to your point around like climate impact and flood risk, is looking at downscaling. Okay, and this is so downscaling is how we basically turn the low resolution outputs of a climate projection model and turn it into something much more high resolution, which has like real use for looking at things like different. So this was a flood that happened in Western Europe in 2011. These are the flood extents in Germany. And you can see, right, these are very kind of narrow valleys, right? There was an extreme kind of extended precipitation event. It caused flash floods, caused the river to rise like 10 meters above its usual level, destroyed millions of buildings, homes, and it killed like 200 people. This event. And as you can see, this is a very like small scale local thing, right? It relies on local information, local inputs about, in this case, precipitation. So if we now go and look at what the output of a climate projection would look like. So this is now, we're looking kind of end of the century. So this is rainfall data predicted from one of these models.
So by the end of the century, this is how the rainfall will look like?
So this is like one
2095.
So this is 2095, and this is like one particular model output. And so you can see it's quite low resolution, right? It's very pixely, right? Each of these pixels is like 150 kilometers across.
So that much rain is going to happen after 60, 70 years? So much rain?
I mean, we obviously don't know exactly where the rain's going to happen 100 years ahead, right? But we can, like, the output from these models can give you an idea of what...
Is it a time series slider?
Yes, that's
Can we reduce it to 2025?
Oh,
like
no,
next
so
year?
This is just from 2095. But the idea is that this is very low resolution, but if you want to look at something which captures that high resolution information that you would need to do forecasts, like understand the impact for local areas, so we can train our AI models to take the output of those simulations, and simulations at this resolution are already massively computationally intensive, right, to run. People can run simulations at high resolution, but they're so expensive to run in terms of the amount of compute you need that people can only ever do them for much smaller regions and with a very limited set of different like scenarios. Right? So we need a way of scaling that up, basically. And this is where AI comes in, right? So by fine-tuning our weather and climate models to take this sort of information, this sort of output, and downscale it to this sort of resolution, we can then enable a task to take the resolution from low resolution to high, instead of taking maybe days, weeks or months to run those models. We can do this in kind of seconds to minutes time.
So if I get the data for the past 100 years for the month of May in the US, can I predict where the floods or earthquake or these things are going to happen this month?
So you could apply these sorts of techniques to more short-term forecast data.
And how much is the accuracy?
And then that would feed, and then you would then feed that into a flood model, into some hydrological models. But it would help you understand
any
where the risks
percentage,
are.
how much accurate? 20, 50, 70% accuracy?
So we're still, this is kind of, so there are different ways of measuring like the improvement in the performance. So in terms of measuring the accuracy, we're still trying to figure out actually what is the best metric to do that, right?
Okay.
So we're still quite early on in this process, especially when we're looking at climate timescales.
So we can access the IBM Geospatial Studio online. Just go register it, or it's a paid service.
So it's not publicly available yet.
Not
but if
publicly.
you're interested to try it out, to find out more, you should please just scan this.
I just scanned it already.
There's a blog, and there should be a link to a sign-up page where you can sign up.
Because we are into generative AI, and we are doing for fintech and biomedical AI.
Okay, great.
So we are not into climate part, but I would love to explore that also.
Sure. And we have lots of colleagues in other bits of IBM research who are trying to do similar things, but with other modalities of data, like healthcare, life sciences.
Okay. My name is Taranjit. I am the CEO of Your Grace Incorporated.
Okay, excellent. Nice to meet you.
Thank you.
Great. Oh yeah, sorry.
The actual prediction.